In the previous video, we had a discussion on optimization goal, then network architecture, what are the different network scenario. That was a discussion for the previous video. So this video we are going to see about design principles for WSN. So before going to design principle, already we had a discussion network architecture, types, then what are the different sensor network scenario we had, then how the architecture is based on multiple sink, multiple source, then what are the different sources of mobility, how it is defined, then under optimization goal, quality of service, energy, scalability, then robustness. That was the discussion for the previous videos. So today we are going to see about the design principles of WSN. So design principle, which is like, even though we have an appropriate quality of service, energy efficiency, they are the important design and optimization goals for WSN. But it will not provide and hints how to structure a network, right? So how we are going to structure a network, that is the reason we are going to discuss on the topic called design principle. So in design principle, the first one is about distributed organization. So distributed organization, that means there should be no centralized entity in charge, such as entity could be. There is a distributed organization, there is a participants in a MANET or WSN should cooperate in organizing the network. It is like with respect to how the medium access, how the routing, and how the approach is going to use it. So centralized approach is alternative, usually it is not feasible. That means there is a problem. While for the discussion on the robustness and the scalability nature, that is the reason in WSN for network organization, they are going into distributed organization. If they are going centralized or distributed, there are some potential shortcoming problems over there. And the shortcoming problems are like, out of these problems, they were identifying which type of organization we should look for. That is like either it is a centralized or it is a distributed organization. And moreover, we have to identify the distributed and the centralized one based on the energy efficiency. While you are concentrating energy efficiency, it has to take all the overheads into an account. So there are normally limited centralized solution. They are electing the nodes for local coordination or control. So it perhaps rotating these functions over a time. So here they are using the concept called the election in the hierarchy. The election process, it will be repeated continuously, lays the resource of elected nodes to be overtaxed, or the elected nodes runs out of energy. The robustness will be the disadvantages. So generally in this WSN, they are going into a distributed organization. The next one is about in-network processing. So in-network processing, which is not only passing the packet or executing application program, they are actively involved in taking decision. That is what the network processing talks. So it delivering the bits from one end to another. So while the deliverance, they have to identify whatever the problem are involved and what are the decision they are going to take. That is very important. On the other hand, they are expected to provide the information. It gives an additional option, that is like manipulation or processing. And moreover, the transport by the network into account this information processing in network, it is like the first rank of the design principles. Then comes to for aggregation. The next one is about aggregation. Aggregation means it is like in summation. So it is going to be aggregate the function to a converged caste tree in the network. And the functions they are using in the aggregation, it's like minima, maxima, average, sum. It is like in statistical approaches. So all the statistical analysis they have used for aggregation, even, median, mode, they are all the functions they are using in the aggregation process. So the aggregation process is, it's like in classification techniques they are using. It is like algebraic versus holistic, or it is like monotonous or non-monotonous. Likewise they are using. So the aggregation function, it's like average counting. It's like they are using in the aggregation operation of network processing. So how it could be? You can just look at the diagram. There is reducing the number of transmitting bits or the packets by applying an aggregate. The first figure, when you are looking at, there are like some numbers indications over there. So just look at here. This is the first node, second node and the third. So the summation, that is aggregation. So totally we have 3. Then comes to this point, you have 3 nodes, then again one more 3. So total aggregation is 6. So out of these 6 nodes, how many aggregation values your sink is going to receive? That is 6. But the same thing for the repetition. So just they are taking into an average account. So all the time only 1 is received by each group. There is no aggregation. There is no summation process. Simply they are just collecting the values and the value is sending to your sync point. This is how the aggregation. So this aggregation, what it will do, it will reduce the number of the transmitting bits packets by applying an aggregate function in the network. That means there will be no redundant as how long it has to wait for such results and determining the impact of the last packets. So that is what happening in the aggregation principle. The next one is about in network processing. The first one is about the signal processing. So it depends on the application how more the sophisticated processing of data can take place within a particular network, but depends on the application. The applications, the examples are like edge detection, tracking, angle detection, then temporal and spatial correlation. So for edge detection, which is nothing but it is exchanging the raw data with the neighboring nodes and it computing the edges. Only it will communicate the edge description far away from the data sinks. Then for tracking, the example of some sensor nodes, how they are going to be. So just like that they are tracking, as well as the angle also detected by the signal source. So the conceive it like sensor node as a distributed microphone array. Using that they are just computing the values. So they are not only communicating the angle, also it collecting all the raw data which was using in the process. Then temporal and spatial correlation, that is nothing but the observing signals might vary only in time. There is no need to transmit the data for a full rate. So the signal of a neighboring nodes are often quite similar. Then adaptive fidelity. Adaptive fidelity, which is nothing but how it is adaptable, how much the data exchanging to the currently required accuracy. So it's like they are just identifying event detection. If there is no event, then there is no sending. No event means only a few data is going to happen and it will give a message. Okay, all is well. Then when there is an event occur, then another message will comes. So the event is like I am just measuring the parameter is temperature. Then if the temperature is in acceptable range, okay, then we'll send the temperature value at a low resolution. If it is going to high, then it will increase the resolution. Accordingly, the message will be given. So the adaptive nature of a particular application we have. Then the next one is called the data centric networking. So data centric networking, which is like a typical network, it includes address data as well as the nodes. A typical network including ad hoc, its transactions are addressed to the identity. Identities are like node centric or it is address centric. So it has to find out which paradigm they are going to use. Either it is node centric or it is address centric. If there is any redundancy of redundant deployed sensor networks are there, then that has to given along or that has to given some event. Then for focus networking transaction, there they have to send the information like sender and the transmitter. So that is how the data centric networking. Then how it is going for implementation operation. So implementation, there is an called DHT, that is distributed hash table. So the hash table, it is like a content addressable memory. So it will give and retrieving data from the unknown source. Then if there is a key, dynamic changes or static keys over, or if there is any issues, that will be looking into account. Then there is a publish or subscribe, that is different interactive paradigm. Nodes can publish the data and also it will describing the data. So once the data of certain type has been published, then it is delivered to all the subscriber. Then the subscription and the publications are decoupled in time. So the subscriber and published are, they are decoupling in nature. So that could be either it has to go for published or the subscribing part. Then there is a concept called databases. So when you are talking on data centricity, if there is an overlay network or distributed hash table, these are the implementation options of data networking, data centric network. So there is a concept called publish as well as subscription. That is also very important for the implementation option for data centric networking. Then for further design principle, they have to give the information of location, then activity pattern, then they have to given the types of network, how many nodes are to performing a different task operation. Then one more thing is called the cross layer optimization protocol stack. Already we had a discussion on cross layer. So the same thing here also we have to concentrate while we are going for design principle. Then what are all the interfaces for the protocol stacks? So it is like an requirement, how the identifying of addressing the data, how it is accessible, how you can specify the accuracy and the timeline requirement, and how it could be security and the management. That is also noted for this protocol stack operation, and how far it is supporting the request as well as the response interactions, then event notification, whether they are locating the value or it is an observed value. Likewise, they have to give the information. Then gateway concept. The next one is about gateway concept. It is necessary for the internet for remote access, right? So you have a remote users, you have an internet, and through which the gateway node, they are just transferring the data to the WSN. So the same thing, some additional complication, it is due to the mobility. So there is the bridging the gap between the different interactions, how the gateway node is connected via internet to the WSN. So another configuration is in between you have an internet and the desktops are also connected. Using this gateway node, they are just identifying which source is going to connect it with an alias supporting. That is also we can able to find out the gateway. So that how they are identifying the routing as well as the service, and moreover they are just finding the best gateway if there are more number of datas are available. And the third one is about how the connections, that is internet, you have a remote requester, gateway node and the gateway. The next one is about the this same thing is used like a tunneling. How the gateway node and this way is connected.